Unit 1, Activity 6, Systems of Linear Equations. In previous activities, we explored many examples of situations in which two quantities have a linear relationship. We found linear equations that model those relationships and used the equations to make predictions. In this activity, you will solve problems that involve two linear equations. And in these situations, we will have two unknown quantities that we want to find. If there are two unknown quantities, there are two variables, and we need two equations in order to find a solution. Again, we're going to need two equations to find a solution with those two variables. In this activity, we will practice using tables, graphs, and equations to solve such a system of two linear equations. And these are the learning outcomes. You will explain your reasoning and meaning of solutions in context. You will solve problems with one method and check with another, and you will model solutions and solve problems using tables, graphs, and equations. You will also solve a system of equations using tables, graphs, and equations and technology. Let's start with a warm-up. Number 1. If y equals negative 3x plus 4 and y equals 10, then what is x? So we have a value of y. We substitute this to this equation. So the value of y, we substitute that here. So 10 equals negative 3x plus 4. Then now we can solve for x. So we just have to isolate x. So what we do is, yes, subtract 4. 10 minus 4 is 6 equals negative 3x, and then divide both sides by negative 3, and so that x is equal to 6 divided by negative 3 is negative 2. Okay, then number 2, if y equals negative 3x plus 4 and x is equal to 10, we have to solve for y. So we have a value of 10, x, which is 10. We substitute that here. So let's do it. So y equals negative 3 times 10 plus 4. Negative 3 times 10 is negative 30 plus 4 is negative 26. Okay, then number 3, if y equals negative 3x plus 4 and y equals 2x minus 6, then solve for x. We can use again a substitution here. Since we have these two equations, both are equal to y, so meaning we can set them equal to each other. So you can write negative 3x plus 4 equals 2x minus 6. Okay, or if you think it this way, since this is y equals to 2x minus 6, you can plug in that to the y here, or vice versa. You can plug in this value to the y here, and you will get this. Negative 3x plus 4 equals 2x minus 6. Now let's solve for x. So what we do, if we subtract 2x both sides, 3x minus 2x negative 5x plus 4 equals negative 6, and then subtract 4 both sides. So negative 5x equals negative 10, and divide both sides by negative 5, so that x is equal to negative 10 divided by negative 2. Negative 5 is positive 2. Okay. Next, number 4, if 3y plus x equals 10 and y equals 2x minus 6, what is x? So we have a value of y here, and we can substitute that to the first equation here. So you can write it 3 times this value of y, 2x minus 6 plus x equals 10. Then distribute 3 times 2x is 6x, 3 times negative 6 is negative 18, plus x equals 10. Combine like terms, or you can add 18 both sides. 6x plus x is 7x. 10 plus 18 is 28. And when we divide both sides by 7, x is equal to 28 divided by 7 is 4. So that is the answer. So if you notice about all these problems here, number 1, number 2, number 3, number 4, I highlighted those like number 1, y equals 10. We did substitute that to the y of this equation. Then number 2, x equals 10. We have a value of x. We substituted that to this equation. Same thing here, y equals 2x minus 6. We did substitute that to the value of y. Same thing here, y equals 2x minus 6. We did substitute that to the y here. So that is exactly what we've been doing here. We are substituting. So we did substitute those values. Okay. So let's start with our class discussion for this activity. By the way, you will always see this when you check your math theory packet. So this is activity 6. Okay, let's start. Number 1. 2 lines in the graph represent the profits of companies A and B in thousands of dollars. Let x be the number of years from 2000. Letter A, what conclusions can you draw about each company and about the companies in comparison to each other? So you will see here, this is company A, and this is company B. So green and blue. So company A, what conclusion can we draw about company A? Your x-axis, that is the number of years since 2000, and your y-axis, that is the profits in thousands of dollars. So we can say that company A in the year 2000, at the beginning, it had a profit of $20,000. And since your x-axis is the number of years since 2000, so every year, how much is the profit? What's the increase? So remember, that is the slope. Say from this is a year 2000, and after a year, this is 2001. Rise over run, you go up. That is, you go up by 15,000 and 1 to the right. So that is, you have 15,000 increase per year. $15,000 increase per year. Okay. Company B is here. It started at 35,000 profit. In year 2000, the profit was 35,000. And let's check. So from this point to this point, after a year, we can see that if you go up, that is from 35 to 45, so that is 10,000 per year. So that is 10,000 increase per year. Okay, so we use here, we know, just to recall, y equals mx plus b. B is the y-intercept that is at the beginning, so that's why we have the equation for company A, 15x plus 20. So it started at here, $20,000 in thousands of dollars, so that's 20, and then the slope is, it says here, 15,000 increase per year, so that's why we have 15x. And then company B is 10x plus 35, so in the year 2000, it had a profit of 35,000 here, and then the slope is, you go up 10, which is 10,000 every year, so 10,000 increase per year. So that's why you have this equation 10x plus 35. Now we're going to solve these two equations using the method of substitution. So we can rewrite company A, we have y equals 15x plus 20, and company B, y equals 10x plus 35. Since they are both equal to y, you can substitute, let's say, this to the y of the first equation, or this to the y of the second equation, or in other words, you can set them equal to each other. So 15x plus 20 equals 10x plus 35. And then now we can solve for x. And don't forget to get the x value and the y value. To solve for x, subtract 10x, 15x minus 10x is 5x, plus 20 equals 35, then subtract 20, and I'm gonna write it here, 5x, 35 minus 20 is 15, and then divide by 5, so that x is equal to 3. And then to solve for y value, we can plug in this value of x to either of the two equations. So let's say the first one, y equals 15 times 3 plus 20. 15 times 3 is 45, plus 60 is 65. So these are the x and the y values. So 365. So this is your x and this is your y. And then letter C, explain what your solution in part B means in the problem situation. Remember to use specific numbers and units in your statements. So here, you know, our x values, that is the number of years since 2000, and the y is your profit in thousands of dollars. So we can say that since your x is 3, our computed x is 3, so since 2000, after 3 years, that is in 2003, we can say that company A and company B, or both companies, earn the same profit of $65,000. Okay. Now, letter D. Use technology to graph the two equations, 15x plus 20 and 10x plus 35, and use the technology to find where the two lines intersect. Compare your answers to the solution you found in part B. Alright, so let's try this and use our Desmos. So again, all you have to do is go to desmos.com and enter this. So here's Desmos. Enter y equals 15x plus 20 and y equals 10x plus 35. So what do we have here? So you can see that you see 3 and 65. So that is the point of intersection. So the two lines, the two equations, as you can see, the blue line and the red line, intersect at the point 365. Okay, so again, with your Desmos, all you have to do is just enter the two equations, y equals 15x plus 20, y equals 10x plus 35, and you will be able to see where the two lines intersect. By the way, from our notes, if you want to use a of x or b of x, as you can see that is still the same thing. So you can use y or a of x and b of x. Back to our notes, we can say that they have the same solution of 363 and 65, which is the point of intersection, where the two lines intersect. Next page. Most systems of two linear equations will have a common meaning point or point of intersection. There are some unusual systems, however. Problems 2 and 3 below illustrate examples of those. So number 2, use the equations f of x is equal to 2x minus 5 and g of x equal to 2x plus 6. And we're going to use technology, Desmos again, to graph this two equations and find the intersection point of the two lines. And you are going to reproduce a sketch of your, rough sketch of your graph here. You have the space here. And again, we are going to use Desmos. Alright, so type the two equations here. F of x equals 2x minus 5. That's the red line. And then g of x equals 2x plus 6. The blue line. So if you move this, what can you say about the two lines? So even if you zoom in, zoom out here, as you can see that the two lines do not intersect. You agree? What do you call these two lines that do not intersect? Yes, they are parallel lines. Based on Desmos, we know that there is no point of intersection. And when we graph it, you saw blue and red lines, and they are parallel lines. Letter B, they do not intersect. Solve the system of two equations by using the method of substitution, and what happens? So again, here, the first one, f of x, if you want, you can rewrite this as y equals to 2x minus 5, and the other one is 2x plus 6. They are both equal to y. You can set them equal to each other. So 2x plus 5 equals 2x plus 6. Sorry, yes, that should be minus. And if we subtract 2x both sides, 2x minus x is 0. And if we add 5 both sides, 2x minus x is 0, 6 plus 5 is 11, and we can say that 0 is not equal to 11. So that's why we can say here that no solutions. And based on our graph, we can see that there is no point of intersection, so meaning there are no solutions. Okay? Next, number 3. Consider the system. We have two equations here. 2x plus 3y equals 6 and y equals 2 minus 2/3 x. Solve this system by substitution. So look at your second equation. Y equals 2 minus 2/3 x. You have a value of y, so meaning we can substitute this value to the y of the first equation. So the first equation, 2x plus 3 equals 6. So substitute that value of y here. So 2 minus 2/3 x. So see what we did here. And then simplify to solve for x. So 2x plus 3 times 2 is 6, minus, multiply this, 3 times 2 is 6, divided by 3 is 2x equals 6. And 2x minus 2x is 0, so this is 6 equals 6. And when they are equal to each other, so we can say that we have infinite solutions. See the difference between the two. Number 2, if they're not equal to each other, no solutions. If they're equal to each other, infinite solutions. Okay, so number 4, compare your work in problems 2b and number 3 above. Write down a summary of what the solutions to a system of equations is in these unusual situations. Be sure to clearly differentiate between the two different conclusions. So what can we say about from 2b? We got here that, what do you notice about these two equations here? Look at this. They have the same slopes, same slope of 2, different y-intercept. So meaning they are parallel lines and no point of intersection. So we can write it down here. So when two linear equations have the same slope, and different y-intercept, they are parallel lines and no point of intersection. So parallel lines do not intersect. So let's say this line and this line. So these are two parallel lines. And for number 3, problem number 3, these two equations here, we got infinite solutions. So we can say that when two lines are coincident, meaning the same line, so meaning they intersect at all points. Okay, so again, when two lines are coincident, that is meaning they are on the same line, they intersect at all points along the line. And when that happens, we can say that infinite solutions. So when you graph that, when you use Desmos, you will see that there, let's say the first one, 2x plus 3y equals 6, something like this. And then the other one, when you graph it, is another line. So graphs are exactly the same line. Okay, so that is number 4. Next, number 5. The following table lists values for two functions f of x and g of x. Take a look at the table and then use the table to find the solution to the system of two equations. Use the table to find the solution to the systems of two equations. Remember, when writing a solution to a system of equations, be sure to give both the x value and the y value. Okay, let's go back to the first problem here. We got the point of intersection at 365. So meaning when you have these two equations, they both have the same x and y. X is 3 and y is 65. So when you look at the table, it's going to be the same thing. So you have f of x and g of x. When do they have the same x and y? Here. So meaning f of x that is f of -1 is equal to 6, and also we can say that g of -1 is also equal to 6. So that means their point of intersection is at -1, 6. X and y. So that is the solution to the systems of two equations, -1, 6. Okay. Okay, number 6. We can also estimate the solution to a system of two equations using the table when the precise value is not listed. The table below shows the populations of two fictitious towns over a number of years. So our x values, that is the number of years after January 1st of 2000. The x value is 0, 2, 5, 8, 10, 13, 16, and 19. And then y1 is the population of town A with these values, and y2 is the population of town B with these values. So we're going to use this table to estimate the solution for the system of two equations. So remember, you learned this from the past activities our lines is y equals mx plus b. So if we're using the first line, y1, we need a slope and a y-intercept. The y-intercept, remember, that is when x is 0. So we have b for town A, and we have b for town B. Okay, but now we want the slope. So let's say from 0 to 2, so we get the difference between this, a change in y over a change in x. So we can say that 3004 minus 2500 over 2 minus 0, that is equal to 504 over 2, which is equal to 252. You can try another one if you want, from 8 to 10, and these two, when you subtract 5020 minus 4516 is also equal to 504. 10 minus 8 is 2. 504 divided by 2 is also 252. So we can say that the equation for this town A is the slope is 252x, and your y-intercept is, when x is 0, that's 2500. Okay, now let's try for town B. If we do the same thing, so these two, 9540 minus 10,068 divided by 2 minus 0, and what is 9540 minus 10,068 is negative 528 over 2 minus 0 is 2, and this is equal to negative 264. So meaning your y2 is, this is the slope, negative 264x, and the y-intercept when x is 0, that is 10,068. So those are the two equations. Now letter B, explain how you find the estimate, the solution for this. So now we have these two equations. We can solve for x and y. So let's make them equal to each other. So 252x plus 2500 equals negative 264x plus 10,068. So if we add 264x both sides, and at the same time you can do this, subtract 2500 both sides, so you will have 252 plus 264 is 516x equals 10,068 minus 2500 is 7568, and then divide both sides by 516. You will have x is equal to 14.67. And then you can solve for y. You substitute this to either of these two y values. So let's say if you want the second, negative 264 times 14.67 plus 10,068, and you will have y equals 6196. So the solution for this problem number 6, I'm going to write it down here, is you have 14.67 and 6196. So this is the point of intersection. Okay. Next. Number 7. Company A started in 2010 with a revenue of 15,000. Every year after, they had a steady revenue increase of 4,000 each year. Company B was founded in 2012 and had a revenue of 10,000 in its first year. Thereafter, Company B increased its revenue by 6,000 per year. Letter A. In order to solve a system of equations, the variables definitions for each equation must be identical. Define variables of each company. So A, Company A and Company B. So we can say that the X, let's say X is the number of years since 2010, because they started in 2010. And Y is the revenue increase in thousands of dollars. For Company B is also the number of years, but this one is since 2012, and their Y is revenue, again increase in thousands of dollars. Okay, so those are the two variables for the problem. That is for each company. Okay, that's letter A. Letter B, create a table of data for each company. And remember the variable definitions from part A. So let's have X. Let me use and Y. So let's say since 2000, let's say I'm going to start at 0, 1 at the end, because that's every year, 2, 3. So think that this is 2010, 2011, 2012, 2013. Okay, and they started with a revenue of 15,000, so in thousands of dollars. That is, let's use 15 here, and a revenue increase of 4,000 each year. So 15 plus 4 is 19. 19 plus 4 is 23. Plus 4 is 27. So that is for Company A. And Company B, I'm going to use X and Y here. I'm going to start at 0, 1, 2, and 3. So think that this is at 0, they started in 2012. So this is 2013, 2014, 2015. Okay, so they had a revenue of 10,000. So in thousands of dollars are Y, so this is 10, and increase by $6,000 per year. So 10 plus 6 is 16, plus 6 is 22, plus 6 is 28. Okay, so this is our table of data for each company, and we use these variables X and Y. Now to continue that, we are going to create equations for each company. The first one, remember, Y equals mx plus b. Company A, the revenue increase is 4,000. So we can say that this is 4x plus, and in the year 2000 they started with 15,000, so that is 4x plus 15. And company B, Y equals, the revenue increase each year is 4,000, so that is 4x, and they started, 6x, that's correct. 6x. The increase is 6,000. Revenue increase each year is 6,000, and they started with 10,000, so 6x plus 10. So those are the two equations. And then algebraically solve this using systems of equations. So remember what we did? Since they're both equal to y, you can make them equal to each other. So 4x plus 15 is equal to 6x plus 10. So if we subtract 6x both sides, 4x minus 6x is negative 2x, plus 15 is equal to 10, and then subtract 15. So this is negative 2x equal to negative 5, and then divide both sides by negative 2, so that x is equal to negative 5 divided by negative 2 is 2.5. And then solve for y. Don't forget to solve for y. You can use either of the two. So let's say this one, since I'm on this side. So y equals 6 times 2.5 plus 10. 6 times 2.5 is 15 plus 10. So y equals 25. So here, meaning the point of intersection is at 2.5 and 25. So they have the same revenue after 2.5 years. And that is 25,000. So we can see here, I'm showing you the two tables here. This is company A and this is company B. 2.5, if you add a 2.5 here, 2.5 here, between 23 and 27 is 25. So that is the revenue, 25,000. Same thing here, at 2.5 between 22 and 28 is going to be 25. So that's why they intersect at 2.5 and 25. Okay, letter E, use technology to graph the two equations from part C and find the intersection point. So here type the two equations, y equals 4x plus 15 for company A and y equals 6x plus 10 for company B. And you'll see here their point of intersection. So we got 2.5 and 25. That's exactly the same thing when we solve systems of equations. Again, back to our notes, and I showed you with Desmos that they intersect at 2.5 and 25. So we solve it algebraically, and we use Desmos, and they get the same point of intersection. So note, if your answers do not match up, then check your work for errors or ask for help. And please, I'm always available. If you need help, attend my office hours, or please attend MATLAB. Okay? And I'll see you next time. Thank you.